Good morning, everyone. Today, our team, Hatem Shakweer, Lina Hamad, Yahia Sherif, Yousef Ibrahim, and myself, Yahia Hassanein, are going to present to you our product, Glasses for the Visually Impaired, which is supervised by Dr. Mohamed Shalan. Our agenda for the day is that first, we will tell you the motivation behind our product and the feature it supports. Then we will talk about the software and hardware tools used. After that will be our intended future work to enhance the product and show you the product's demo. Finally, we will discuss the updated business canvas and our cost structure. Our problem statement is that visual impairment eventually leads the person to become fully dependent on those around them, which makes their life tough and even prevent them from getting proper education. So that's why our goal was to implement an affordable commercial product that will empower the visually impaired to lead an independent life. As for the feature that the product supports is first face detection, then text-to-speech that supports both English and Arabic languages, money bill detections, obstacle detection, voice commands that also supports both English and Arabic, including the Egyptian slang. It also recognizes hand gestures, and it has a chatbot that can communicate both in English and Arabic. Now I will leave you with Hatem to tell you more about our system architecture.
For our system architecture, we have the smart glasses itself consisting of the printed frame, the camera, communicating the stream to our mobile app, which on itself communicates with our backend and retrieves the results according to the features deployed. For the tools for development, we have chosen Flutter to develop our app. First of all, because it's a cross-platform environment. With the same code base, we can deploy both iOS and Android apps. Moreover, it has a very strong documentation, and it has a small but an active and very rapidly growing community, which means that it's very rich in packages that we can use to enhance our features. Now, we will walk you through our features. First, for the voice commands, we are using a Flutter plugin that uses a native iOS and Android voice recognition as a base for our voice command implementation. It supports both English and Arabic voice commands to trigger one of our other features. For the face detection feature, we are using Firebase's machine learning kit to detect faces and images. It also can detect smiling, and according to the probability of closure of the eyes, we can also detect if the person is sleeping or not. Next, we have the read text feature. For the English language, we are using also Firebase machine learning kit to detect sparse text and images, and then we play it back by sound to the user. It's one of the perfect solutions in real time and has a good accuracy. However, it supports only Latin-based languages, so I will leave you with Lina to continue on how we implemented the Arabic read text.
So for the Arabic text-to-speech, we will split this into the OCR and the text synthesis. For the OCR, we use Tesseract OCR, which was originally owned by HP and later acquired by Google. It's an open source optical character reader engine, and basically Tesseract is built on a neural network-based engine, specifically long short-term memory recurrent neural network architecture. And it basically works on two steps. The first step would be the character recognition part, and the second step would be the character filling, where it basically checks what the most suitable letter would be here in the word and in the sentence. Maybe the only downside to this is that the accuracy depends mostly on the image quality. Moving on to the text synthesis part, so we used Google Cloud Platform, and in specific, the text-to-speech API. It has 30 different languages and their variants. However, we're only using the Arabic as it's a bit costly. After you read your first 1 million characters, it starts billing you $16 per 1 million character. So moving on to the chatbot. So why are we using a chatbot and not a live chat? Well, basically, it's so much cheaper and more reliable than having actual people responding and having salaries and so on. Currently, our implementation is using Google's Dialogflow. And basically, how does that work? When the user speaks out their request for help, it goes on and checks it against the training data that we did on both English and Arabic sets. And it looks for the most suitable response based on either keywords or full sentences to respond back. The cost is actually pretty good. Having this feature will always be free for our part, as even our target customers will never reach the enterprise level with their amount. And now I'll leave you with Yousef, who will continue on the money bits.
Okay, to implement the money-based detection feature, we are basically counting on the differences found between each pill, which can vary in color, shape, and size. This was done by mainly using two of Python's computer vision libraries, which are OpenCV and Pillow libraries. The algorithm behind this is pretty simple. We start by supplying a template image set to the algorithm, and then supplying the input image that we actually want to check its currency, and then we run them both by the structural similarity index matching function, which perceives the change in structure information by comparing subsamples in both images, rather than just perceiving the percentage error like in the mean sum approach, for example. And finally, we detect the best match. And now I'll leave you with Yahya to continue with the hand gesture applications.
Okay, so now for the hand gestures, it allows the users to trigger a certain functionality from the application itself. For this to happen, we need first to detect the skin color of the hand. And as we do in the second picture, it extracted the hand with some background noise. We then filter out this background noise and take the largest connected component and compare it to the number of hand gestures we have in the data set. For this hand gesture, it tells us the current time for the user. So for detecting objects, we're going to use YOLO, which is one of the best detectors nowadays, and that can operate in real time. It is one of the largest models, as it's being constructed of 106 convolutional neural network layers, and this introduced some delay in this model, and it takes around 1 second to complete the detection, depending on how big is the picture. However, in return, it has boosted its accuracy, and it can detect smaller objects, which was a problem in previous models. Okay, so on the left side, we have the input image, which is fed to the YOLO model, and on the right, we are having the output image with bounding boxes around each of the objects that being detected, with the confidence being on the top. So in order for us to integrate our machine learning and computer vision codes to the mobile app, we started using the recommended plugin, which is supported by Google, which is Starflot. However, the Starflot is underdeveloped right now, and it has a lot of errors, and we couldn't use it. So we had to switch into APIs. So we have used Connexion, which is a framework built on top of Flask, and we have connected it to a server so that we can easily communicate with our mobile app. So now Yousef will continue with the hardware.
Okay, so as for the hardware, we have chosen Raspberry Pi Zero W as our microcontroller. That's because it's small in size. It streams video through Motion, a video streaming library installed on the chip itself. The camera associated with the chip is a 5 megapixel camera, and the total cost of the camera, the chip, and the wiring runs about $45, which is relatively cheap compared to the other chips. Now, to choose the ideal battery, we have measured the consumed current in different performing stages, and we concluded that given the available options in the market, we found it best to choose two 400 milliampere batteries with the power supply of 3.7 volts in order to run the chip. After deploying the battery and exhausting its power, we concluded that the chip can be able to stream for 1.5 continuous hours. We have also packed the battery with a charging module to recharge the battery, and the costs are pretty reasonable given that it's around $10 for the batteries and $3 for the charging inside. As for the 3D printed glasses, we did not actually succeed in doing this task due to the current situation. However, we did achieve to find a design online that best suits our design. It is done on Unity, which allows us to customize the color and the size to what suits our components. And the glasses are made up of two separate components that are printed separately: the frame itself and the container to hold the components in place. The container has stripes in order to be attached to the printed frame or any other frame of the user's choice. Having all these milestones done, we still think that we can make several enhancements to our product. for text recognition feature, we think that it will be better. It will be an upgrade if it can actually recognize handwritten text. We also hope to achieve better portability in the future by using smaller hardware components, referring to the chip and the battery, of course. As for the currency detection, we hope to minimize the limitations that this feature comes with. For example, the feature does not handle reading bill if they are rotated by a significant angle, and so far the algorithm only supports Egyptian currencies as its dataset. And right now we are working with a 5 megapixel camera, but of course we can achieve better results if we have a high resolution camera. Finally, we hope to extend the hand gestures so that there will be a unique gesture for each feature running on the application. And now we're gonna show you a demonstration of our application running.
Meet Sarah. Sarah lost her eyesight when she was just 12 years old. And ever since, she always dreamed about continuing her education and even someday finding a suitable job. But her disability was always holding her back. There are billions of people around the world just like Sarah. And this is why we're here presenting you with Lumos, your visual companion. Lumos can read your text. It can also detect obstacles around you. And it can also detect people's faces around you and tell you their emotions. Now let's get started. Pull out your phone, register your device through the app and sign in. This is a one-time process. You might need help during this. You can trigger your features by using voice commands in either English or in Arabic. If you're going to use the English language, you can command your device by saying, detect faces, detect obstacles, read text, or help.
Read text.
The virus that causes COVID-19 is mainly transmitted through droplets generated when an infected person coughs, sneezes, or exhales. These droplets are too heavy to hang in the air and quickly fall on floors or surfaces.
Detect objects.
Bottle 1, chair 1, cup 1, laptop 1, person 1, remote 1.
Detect faces.
2 people, 2 smiling, 0 sleepy.
Detect bill.
1 bill, 100 pounds.
Help, hello.
Good day, what can I do for you today?
Help, how to use your glasses.
Call out the name of the feature that you want to use. Detect faces, detect obstacles, read text.
Help, my glasses are broken.
Email us at help@lumosglasses.com.
If you're going to use Arabic, you can command your device by saying كم شخص وريني اقرأ ساعدني.
اقرأ.
وتأثرت علاقات بعض الموظفين مع العملاء حول العالم إذ كانت أربال زون المسؤولة عن التوسع في الأسواق الناشئة بإحدى كبريات منصات البث المباشر لألعاب الفيديو في الصين تتنقل بانتظام بين آسيا وأمريكا اللاتينية بحكم عملها، ورغم أنها عادت إلى العمل في الشركة لا أن راتبها انخفض انخفاضا كبيرا إذ كان ما تحصل عليه من مصروفات السفر يمثل 60 في السنة.
وريني.
زجاجة 1 كوب 2 لينين تابلي 1 سكين 1 الكمبيوتر المحمول 1 شخص 2 ملعقة 1.
كم شخص؟
2 أشخاص 1 يضحك 1 نائم.
كم جنيه؟
200 جنيه.
ساعدني ازاي استخدم النضارة.
قم بنطق الخاصية التي تريدها من اقرأ أو كم شخص أو وريني.
ساعدني النضارة مش شغالة.
رجاء إرسالي إيميل إلى lumos@lumos.com.
For the hand gestures, pull out your fist in front of the device to know what time it is.
The time is 06:42.
Okay, so let me walk you real quick through our business canvas. So this is broadly our business canvas, but let me take you more in depth into it. So who are our customer segments? Well, basically we are targeting both segments, the B2C segment and the B2B segment. For the B2C segment, we are targeting clients who are visually impaired. And for the B2B segment, we are targeting clinics and retailers. For our marketing channels, we'll be mainly using our official website, communities like Helm organization, and retail stores who will be displaying our product. For our customer relationships, we'll be having a call center 24/7, training sessions for the B2B segment, and online tech support for the B2C segment. For our value proposition, what are we providing our clients? For the B2C segment, we are providing them convenience, mobility, affordability, and reliability in the sense that this device is with them 24/7. They can use it whenever they want, however they want. For the B2B segment, we are offering them a unique product with new technology and an additional revenue stream. So basically, the hardware development and software development are essentially our key activities. And as for the key resources, our most important resources would be our licenses, our 3D designers, and our software engineers. So who will be our key partners? So mainly they will be banks so that we can supply the product for clients who cannot afford it so that we can loan it to them. And moreover, suppliers, investors who can invest in our company, and retailers who will partner up with us to display our product. Moving on to the cost structure, what is it that we're mostly spending on? We're spending mostly on marketing, R&D, our components, the development tools that we need, the production process, and our normal operating costs. And finally, for the revenue streams, we're getting most of our revenue from the glasses sold, from the customer support, as we're providing extra support if a client needs us to go to their home and help them. And from the add-ons, the accessories, they can buy accessories for their device. And finally, for the customization, we have an option that we can customize whichever feature they need specifically in their glasses. So as you can see here, our main rival is Orcam My Eye 2.0. And what makes us incredibly advantaged is our price versus theirs. They have their device at $4,250, while ours costs $125. As for the feature differences, well, we share with them the money bills recognition, the text recognition, the face recognition. However, they have color recognition and we don't. And on the other hand, we have Arabic support, we have obstacle detection, we have emotion recognition and hand gestures, while they don't. Let me walk you real quick through our pricing. So after managing our calculations, we found out that the production cost per unit would be around $48. And since this is a health tech industry, the average trade margin is 30%, which allows us to sell the device at $69 to the retailers and sell it back to consumers at around $125. There are 4 million Egyptians who are currently visually impaired. And by assuming that in the first year, we'll be selling to the A and B classes only, which amount to 10% of that number, this makes our target segment around 400,000 citizens. And by assuming that we will acquire around 1% market share during this first year, this would make us sell around 4,000 devices. And eventually, this will make our revenue amount to $220,000. Thank you so much. Any questions?